it's recording now. So here variable size framing, in the variable size framing, we have to define the end of the frame and beginning of the frame. So this is a very important job here. Okay, here in the variable size framing, we are having two approaches here. Just to define the frame boundaries, we have a character oriented approach and a bit oriented approach. There are two types. The character oriented approach, the first one, character oriented approach, in that protocol, the data to be carried are 8-bit characters. 8-bit characters. The character is represented using ASCII code. So therefore, each character is equal to 1 byte here. Okay. Here again, the address, the header has normally the destination and the source address. Along with that, we'll also have some error detection correction bits, redundant bits. Here, see, this is what is a normal frame. Each byte here, variable number of characters. There are variable number of characters. The size here, from this place here, from here to here is the frame. And frame is added with a trailer here. The trailer consists of the error checking bits, redundant bits, and header has a source address and destination address. And here, since the frame size is not variable, sorry, the frame size is variable, we need to have a flag here, a flag just to define the boundaries of the frames. There are two flags we can see in the yellow color. Here, this particular one defines the beginning of the frame. Here, this defines the end of the frame. Okay. Now, what is that flag? A flag, it may be some special character. It's added at the end of the end of the frame and the beginning of the frame. It is a protocol dependent special character. It depends on each protocol. Okay, protocol. When I say protocol, it will be each protocol is different. For Bluetooth, you have one protocol. For Wi-Fi, you have one protocol. In Wi-Fi also, we have different variations that we will talk later. Then we have wired LAN. We have that is Ethernet. We have another protocol like that. It's a protocol dependent special character. Okay. Now the question here is, what is that special character? We have a very limited number of ASCII bytes, right? There are 128 ASCII characters. You can choose any one of that, any one of them as a flag. Now, there is a possibility that that special character also will be the part of this message. For example, if I choose, let us say E as a special flag, then there is a possibility that E will appear in my message also. Which possibility is that? Then the receiver will misinterpret that. Suppose that E or a flag appears in between the data, then receiver will misinterpret and think that that itself is the end of the frame. Then from here it will be treated as a second frame. So the entire transmission process will be disturbed here. So for this purpose, to fix this problem, a strategy called byte stuffing. Strategy called byte stuffing is used here. Okay, what is that byte stuffing? So it is adding one extra byte whenever there is a flag or escape character in the text appears. Okay, add an extra byte whenever there is a flag. That is, after this flag also that should be added, and if that escape character appears in the message, there also that extra byte should be added. Now you see this example here. In this example, this part, this is a message. It's a data, or what we call the payload. Payload received from the upper layer. Which is upper layer here? Network layer. So payload received from the network layer. Now in this message, you see here, this is just a message. In that message, the special character which you have chosen, flag, that is this one, it appears here. The flag is appeared in the message, and also the another special character which I have used for byte stuffing, that is also appeared here. Remember, this ESC and this flag are not the it is not the end of the frame, and this is not the special character which is used for byte stuffing. Okay, it is received from the upper layer. Now the byte stuffing is added here. You see here, byte stuffing should be added. See, whenever there is an escape character appears here, here again this should be added. Escape character, an extra byte should be added. Similarly, the flag appears here, so here also it should be added. Escape character added. Okay. Remember, here this should not be added. Here it should not be added because that is a flag here. Okay. Only in the data part. Only in the data part. Only in the data part. If flag and escape character appears, then you have to add an extra special character here. Okay. That is sent at the sender side we are doing, and the receiver side here it is received as it is. Assume that there is no error here. Okay, it is received as it is. It is received. Then all these are removed. Okay, this escape is removed. This escape is also removed. Okay, so you get the data to the next layer. It is data sent to the upper layer. Again, it is the network layer sent to the network layer in the receiver side. Okay, and all these additional things which are added, that is header, trailer, flag, all are removed at the receiver side in the data link layer. Okay, so now you can see this is what is sent. This part is sent. The same thing is received here. Okay, I hope you all understood this byte stuffing, why it is required and how it should be done. Okay, now we'll take this one more example here. Okay, one example here. So in this method, byte stuffing, what this example shows, read this. Byte stuff the following frame payload in which E is the escape byte. So, okay, so we are taking E as the escape byte here, and F is a flag byte. Okay, E is the escape byte and F is a flag byte, and D is a data byte other than escape and flag character. Okay, that is this part. This is the question which is given. Okay, now here you see this the payload here. You have F here, E is there here, one more E is there here, then F is there here also, and E is there here. Okay, so you have E and F in between the payload. So we have to stuff this byte. How do you do? Here, see, this is E. For this E, one more byte is stuffed here. This one more byte. That is escape character should be stuffed. Then for this F here, for this F also, you have to stuff one more here, the byte escape character. And for this E, this is a 1, and for another E, this is 1. So therefore, for 2 E's, we have the total 4 E's, 2 from the payload and 2 from the stuffed bytes. Then you have F here, and before F, we have stuffed another 1. Like that, there are 1, 2, 3, 4, 5 extra bytes are stuffed here. Okay, it's very simple. Now, the second example here, it is unstuffing. Unstuffing. Unstuff the following frame payload in which E is the escape byte, F is a flag byte, and D is a data byte other than escape and flag character. So here now we are doing at the receiver side. Okay, this is at the receiver side. At the receiver side, you see here, you can see there are 2 E's here. That means if there are 2 E's, one is the stuffed one. You have to remove that. Here again F is there. Before that you have E. This should be removed. Then again F is there here. Before that E is there. This should be removed. and here E is there. Before that you have E. This should be removed. Like that, after removing all of them, you have this. This E is removed, so you get only this E. This D is here, and this E is removed, so F is here. This D, and here again this E is removed. This F is this. This is removed, so this E is this. This D is this. This D is this. This is like that. So after byte unstuffing, you have this. So this is byte stuffing and unstuffing process in the character-oriented protocol. Okay. Now you have the second approach here. In the second approach, it is bit-oriented protocol. So you will not be talking about any bytes here. Stream of bits. Okay. And here also same problem. Stream of bits means we will be talking about it may be either text message or graphics or audio, video, or any type of message. Stream of bits. And here also same problem appears. Same problem occurs here. Here we use an 8-bit flag. A special character 8-bit pattern flag 011111110 is used as a delimiter to define the beginning and end of the frame. Okay, again this is protocol dependent. Here it is taken. This is taken as the flag. Okay. Now you can see this part is a data from the upper layer. Is a data from the upper layer. It's again variable number of bits because we are talking about variable size frame. It's a variable number of bits. Each different frames will have different size. Again, here you have, you see the flag. This flag indicates the beginning of the frame. This flag indicates the end of the frame. Before we have trailer and header. As I mentioned, the trailer contains error checking bits, redundant bits, and header contains source and destination MAC addresses or physical addresses. Okay. Apart from that, it will also have some other informations. Okay, we'll see that later. Okay, when you talk about different protocols. And here, if the flag pattern appears in the data, bit stuffing is used to differentiate the flag from information, of course. Now, here, how that problem is solved. This pattern may appear here also. Now, this pattern, 8-bit pattern, will appear in the message part also, or in the payload part also. For that, we use bit stuffing here, not byte stuffing. We don't completely stuff one byte. Instead of that, we stuff just one bit here, one bit. What is that bit? The bit stuffing process is adding one extra 0 whenever 5 consecutive ones follow a 0. 5 consecutive ones follow a 0. Then we simply insert an extra 0. Simply insert an extra 0. Okay. So that is how you can differentiate this, the flag and the data. See here, irrespective of whether it is this data or flag. And the same thing is removed at the other side, receiver side. You see this example here. This is a data stream. From here till here is a data stream received. Okay. Data stream received, and here there are, in some part you have 0 1 1 1 1 1. The flag pattern appears here. It is not actually flag, it is in the data, but the flag pattern appears. Okay. And here we have, see here in this part, 0 followed by 5 ones. 0 followed by 5 ones. Irrespective of whether a flag pattern or not, if 0 followed by 5 ones, simply insert 1 0. Simply insert 1 0 just to differentiate flag here. See, that is done here. The framing. This is a complete frame where header, flag, trailer all are added. And along with that, you see here 1 1 1 1 1 0 1 1 1 1 1. So one extra 0. It is, you can see that in the pink color it is written. That 0, it is a stuffed bit it is. Again you have 1 1 0 0. Then again in this part you see here 0 followed by 5 ones. You have to insert 1 0 here. 1 0 is stuffed. So this entire frame is sent from the sender side. with the 2 extra bits. Then this is the frame received at the receiver side, frame received, and here the same thing is removed. The stuffed bits are removed. Simply receive 0 followed by 5 ones. The next 0 is removed. Automatically it is removed. Again here 0 followed by 5 ones. Automatically the next 0 is removed. So you get this payload, which is same as the data sent, or the payload sent here, this side. Okay, data to the upper layer means at the receiver side it is sent to the upper layer, the network layer. So this is bit stuffing. So in short, I'll just go with it. In the bit-oriented protocol, we use 0, 111, 1110 is used as a flag pattern, and in order to differentiate flag pattern with other patterns in the data part, so we use bit stuffing. What is that bit stuffing? Bit stuffing is a process of adding an extra 0 whenever 5 consecutive ones followed by 0 in the data. Okay, so that is what is done here in our example here. Okay, so now let us solve some numericals related to that. So bit stuff the following frame payload. This is a frame payload received from network layer. So in the data link layer, here bit stuffing is done. See here, 0 followed by 5 ones. After that, an extra 0 is added. Then you don't have that similar pattern. Again here, 0 followed by 5 ones. 0 followed by 5 ones, an extra 0 is added. This is extra 0. This 0 is already there here. Then here, again 0 followed by 5 ones, 0 is added. Okay. Then again you recall this. Okay. This 0 is again considered here. 0 followed by, because 0 is inserted here. 0 followed by 5 ones again. 0, this 0 is here. Then 0 followed by 1, 2, 3, 4, 5 ones. After that, 1 0 is added here again. Okay, this one is this, then continues. So we have added total 4 extra zeros. They are stuffed bits in this example. The second example here, unstuff the following frame payload. Unstuffing is done at the receiver side. So here the stuffed bits to be removed. How it is removed? 0 followed by 5 ones. The next 0 is removed. Automatically it is removed. So here you see this 0 followed by 5 ones. This 0 will be removed. So after that you have 4 zeros. So this 0 is removed. So 4 zeros are there. Then again 0 followed by 5 ones. This 0 is removed here. Okay. Then you have continued here the pattern again. Here 0 followed by 5 ones. The next 0 is removed. This 0 is removed here. Then it goes here 0. This 0 is removed. Then 4 zeros and continued. So this is the bit stuffing and unstuffing process. Okay. Yeah, any doubt here? Any students are having any doubt? You can ask me now.
So this method will hold for any flag value, sir?
Yeah, flag value, now we have taken this. It depends on the protocol it is. Okay.
So suppose the flag value changes, I should change the method, sir?
Yeah. Accordingly, you have to change that process. It is.
Oh, okay, sir. Thank you.
Yeah, this is most of the protocol uses this one only. Okay.
So, but how do we know how to change it, sir?
No, that is, we don't know. You don't know. Okay, you don't talk about that. The protocol is already defined. It is clear. It is right.
Okay.
Okay.
Yeah.
Protocol is, there are fixed number of protocols are available in the literature now. They are all fixed. It is. You don't have to worry now. Here in our syllabus, it is only done this one now. They only talk about this pattern now. Okay.
Okay. Thank you, sir.
Any other doubt? Okay. We'll proceed to the next one. So, this is about the framing. Now, another job of the data link layer is flow and error control. Flow and error control. As I said, flow control. In simple terms, flow control. What is flow control? Suppose there is a production unit, production and consumer unit. If consumer rate is less than the production rate, then what happens? There will be overflow of items. Okay, overflow of items, and some of the items may be lost or wasted. So same concept is used here. Okay, so sender is sending the frames. The framing is already done. The sender is sending the frame to the receiver, but receiving rate is always less than the sender's rate. The reason is the receiver has to process that frame. It has to read or receive the frames one by one. Then it has to remove the header. First it has to read the header. It has to read the trailer. It has to read the flag. It should perform stuffing and unstuffing process. It should remove all those trailer header which is added. That is called some processing to be done. Then depending on the address, it should be forwarded to the next node. All this process will take some time. That is called processing time. Okay. Till then, the received frame will be put it into a buffer. What is that buffer? Buffer is a block of memory. Block of memory available at the receiver side. Okay. And all those frames are buffered in the buffer. Okay. Even that memory has a limitation. You can't have a very high storage memory there. A very limited storage space we have. Once the buffer is full, then there is an overflow of buffer. Then there is a possibility that some of the frames will be lost. Some of the frames will be lost. Then your message is lost. Then the receiver has to ask the sender to resend that frame again. Okay. This process is called flow control. Okay. One way is to do that, adjust the sending rate. The sender will adjust the sending rate. How it is sending rate? But again, that has got its own limitation here. Okay. And here we will be talking about the buffer. Now we have two processes here. What happens is there are two, the error control, we already discussed this. What is error control? Error detection and correction method it is. It allows the receiver to inform the sender of any frames lost or damaged in transmission and coordinates the retransmission of those frames. This is called error control. That means, see here, error control means there are two possibilities here. Frames will be either lost or damaged. Damaged means error. The frames received with error, or the frames will be lost either during the transmission. Frames will be lost either during the transmission or because of the overflow of the buffer. There are two possibilities here again. So in either case, whether frame is lost or damaged, in either case, the sender will ask the receiver will ask the sender to retransmit that frame. Okay, this is called error control. That process is called error control. Okay, error detection and retransmission. Now, how it is done? There are different protocols which are available for that. Protocols means the set of procedures or set of rules. Okay, we can't have our own rules. There are some set of protocols which are defined. Like set of protocols. You have set of protocols in the college, set of protocols in examination, the set of protocols when you write weekly exams. So we write, you take your answer book, you write, fill all headers like your USN you write, your date you write. Okay, all those are do that. That's a set of protocols. You can't have your own method of writing, which US already prescribed protocol. Okay, the USN you can't have your own USN. US is already given. So the same thing you have to write. This is called the set of procedure. Similarly, here you have a set of procedures defined for data communication. There are two broad categories, one for noiseless channels and noisy channels. We'll be talking about the noiseless channel, that is simplest protocol and stop and wait protocol. And for noisy channel, we have all these protocols, stop and wait, go back, selective. This is not there in our syllabus. Okay. So this is only, we'll be talking about these two protocols. Okay. Let us see what is that, what are those two protocols. Now, for the noiseless channel, we have a concept called acknowledgement. Okay, we have acknowledgement. When a frame is sent to the sender, okay, frame is sent to the sender, receiver from the sender. Receiver may receive that frame or may not receive. If the receiver receives that frame, then after receiving the frame, receiver will send the acknowledgement frame. Remember, its acknowledgement frame is sent back to the sender, saying that I have received the frame which you have sent. Okay. Again, the sender will resend the second frame. Second frame also will send, receiver will send the acknowledgement for the second frame also. So that process continues. Here, in the first one, the simplest protocol here, very simple protocol which is used for flow and error control. It's very simple protocol. What this protocol is, there is no acknowledgement here. Okay, there is no acknowledgement. Without acknowledgement is done. See here, network layer get data, data link layer. This it is written in the yellow color. So the framing is done here. The physical layer will convert the bits into signals and other jobs, multiplexing, or all the things you will do, and it will send. The frames are sent. And here, receiver will receive this frame in the data link layer. All header, trailer, everything is removed, and the payload is sent to the network layer. Okay. Here again, there is no method to send the acknowledgement back to the sender. The frames will be received or will not be received. Okay, that's very simple protocol, very basic one. It is, of course, it is not used in one. For this simple, see the algorithm. What is simple? It's a infinite loop. Wait for an event. What is that event? Request from network layer. That is request from network layer. The network layer will request sending my data. So that is an event here. If event request to send, if there is a packet to send, if this is true, that means if there is a packet is ready to send, then get data from the network layer, make frame. So this is make frame, then send frame, make frame, send frame. Okay. Then other side again, it's infinite loop. Wait for an event. What is that event here? Notification from physical layer. So it is now it is done in the reverse part. Notification from the receiver layer. So receiver physical layer would receive these bits, and data link layer will wait for the notification from the physical layer. Then if this is true, if an arrival notification, if this is true, then receive frame from the physical layer, receive the frame, extract data, extract only the data and remove header, trailer, flag, everything, then send the frame. Where to send? It is not to the next node, it is to the network layer. Deliver data to the network layer. So that is this algorithm, very simple algorithm. The pseudocode is written here. Okay. Now for that you have an example here. See the example here. What is very simple? Send A is sender, B is receiver. Request is sent, a frame is sent here, arrival notification is done. Request, arrival notification is done. Request, arrival notification is done. Okay. Here assuming that there is no error, because we are talking about the noiseless channel. What is noiseless channel? In the noiseless channel, it is assumed that no error is there. Error-free channel it is. Error-free channel. and it's also assumed that no frame is lost in the transmission and no frame is lost due to buffer overflow. That is called noiseless channel. Okay, since it is assumed that noiseless channel, there is no need of acknowledgement. No need of acknowledgement. So that is why acknowledgement is not there here. So therefore, but it's a very rare case it is happening. Noiseless channel. Most of the channel it is noisy channel only. Okay. Now we have another protocol here. Another protocol, that is stop and wait. Stop and wait. What is that stop and wait? Send a frame from sender to receiver. Okay. Then wait until an acknowledgement is received by the received from the receiver. That is called stop and wait. Okay. Send a frame, stop until when an acknowledgement is received for that frame. That is what is stop and wait. Okay, that protocol is called stop and wait. Now here the acknowledgement frame is acknowledgement frame is there. Data frame is from forward channel. Data frame is from forward channel, that is from sender to receiver. And acknowledgement frame and another frame will come, that is acknowledgement frame. That acknowledgement frame will not have any data. It will have header, trailer, flag. It will have header, trailer, flag. Then also I think flag is not there. Header and trailer will be there. Header and trailer will be there, and the sequence number will be there in the header. Sequence number or the acknowledgement number for the frame. Acknowledgement number for the frame or the frame sequence number. It is there. So here we need an half-duplex link because there will be bidirectional communication. One way, one channel is to send from sender to receiver. Another channel is required from receiver to sender. That is half-duplex because both are not sending the frames at the same time. So that is why we require only half-duplex link. So here you see that similar procedure is done here. Get data from network layer. See here, you see this arrow mark here. Get data from network layer. In the data link layer, make frame, and physical layer will send that. Physical layer will receive the frames from data link layer and send it here. This is a data frame which goes to the receiver. In the data link layer, the frame is received. Okay, an acknowledgement will be sent here for this. An acknowledgement frame goes here. So here, after receiving, if frame has no error here, if frame has no error, you see here, then an acknowledgement frame is created here. It is sent here back to the sender, and data link layer at the sender side will receive this acknowledgement number. Okay. Once it receives the acknowledgement number for this frame, then it will send a second frame. So this is what is that. An event is nothing but a request from network layer. So network layer is requesting, saying that I have a data to send. That is an event here. Algorithm is there here. Then and one more event, notification from physical layer is also there. What is that notification? This is the notification for the acknowledgement frame here. Okay. The other side you have notification physical layer. So the frame will go like this and here. Then here this algorithm, you see this algorithm, while true, repeat forever, that's an infinite loop, can send is the data, allow the first frame to send. If this allow the first frame to send, wait for an event. What is that event? This request from the network layer, that is this one, this arrow mark. Request from the network layer is an event. So once it is true, and when this is true and this both are true, and this is true, this one. First frame is ready and also this one. Then it is, if this is true, then get data make frame, send frame. First get data from the network layer, make frame, then send frame. And make can send equal to false. Why it is false? Because you cannot send until acknowledgement arrives. Okay, you cannot send until acknowledgement arrives. Once the acknowledgement is arrived, this particular variable is made true. Okay, now after that, this is what is happening at the sender side. Send the frame. Okay, after that, wait for an event. What is this event? Here, for the acknowledgement, wait for the acknowledgement. Wait for the acknowledgement. Again, if event arrival notification, that is, we are talking about this event now. Its arrow mark is reversed because that is for acknowledgement frame. So wait for this event to occur. If this is true, then receive frame. What is that frame? Acknowledgement frame. Acknowledgement frame. Then can send. Once the acknowledgement is received for the frame which is sent here, can send equal to true. Make this variable equal to true. Variable equal to true. What is the meaning of this? Acknowledgement is received so that we can send the next frame. We can send the next frame. So this is the algorithm at the sender side. Then at the receiver side, we have only this one. We have only this part. We don't have this because there is no acknowledgement frame is received here. Only the data frame will be received by the receiver. So therefore, we have only this much code. Here again, while true, it's a repeat forever, an infinite loop. Wait for an event to occur. What is that event? Sleep until an event occurs. This event, notification should be received from the physical layer. Once the event to occur, if this is true, once the event is received from the physical layer in the receiver side, then if this is true, that means when the arrival notification is true, then receive frame, receive this data frame, then extract the data. What is that extract data? Extract only the data part, remove header and trailer and flag, all those additional bits which are added, remove that. Deliver only the payload. Here it is called as data. Deliver only the payload to the network layer, upper layer. Okay. Then there is a send frame is also there here. There is send frame. What is that send frame? Send frame is nothing but an acknowledgement frame. Once the frame is received here, then an acknowledgement frame is sent from receiver to the sender. Okay, is it clear? This algorithm is clear. Okay, I'll repeat this. This is for sending frame to the sender, from sender to the receiver. Here, this is to receive frame from sender. This is at the receiver side, receive frame, and send an acknowledgement frame to the receiver. And here, this part of the code is to receive acknowledgement frame from receiver. This is happening at the sender side. Okay, like that. So this is a pseudo code for the algorithm. Now this example is here. The sender sends one frame and waits for the feedback. What is feedback? It's an acknowledgement here. When the acknowledgement arrives, the sender sends the next frame. Okay. Here, this is the frame is sent, arrival notification is there, frame is received, then acknowledgement is sent. Until then, sender goes to the sleep mode here. Sleep mode. Then the second frame is sent. Here, acknowledgement is sent for the second frame. Like that, it continues. So this is a time. See, till here, from this time to till this, here you can see this. From here to here, the sender goes to the sleep mode here. Okay. It can't send any other. Now, the same thing, one more example you can see here. Here, there is a possibility that the frames will be lost. Okay. During the transmission. Okay. Or an acknowledgement may be lost. Acknowledgement will be lost during the transmission. or acknowledgement will be arrived little later. Okay. Okay. What to do in these three cases? There are three possibilities here. Okay. This first case is the first frame is sent and acknowledged. You see this, carefully see this. The first frame is sent and acknowledged. Okay. Here you see this is a data link layer. Okay, the packet. This is the received data payload received from the network layer. Here, this is started. There is a timer is set here. This is a timer. This is a timer. Okay, timer is switched on here. Timer is switched on. The timer will be expired after the predefined time. Okay, there is a time limit is set here. Maybe 1 second, 2 seconds. Okay. So here the timer is switched on. The frame is sent. Within that time duration, the acknowledgement is received here. Acknowledgement is received. Look at this. The timer is stopped. Timer stops. In the second frame, here, second frame is sent. Timer is switched on again. The frame is lost here during transmission. See here. Frame is lost during transmission. And since the timer is running now, timer will be expired here. Somewhere here it is expired. Okay. The timer is expired and in that duration, within that duration, acknowledgement is not received. Acknowledgement is not received. So the sender will think that the frame has lost during the transmission. So therefore, the same frame, which is the same frame here, the frame 2 here, the second frame in our example. Second frame is resent. It is resent. Then again, the timer is switched on. Timer is switched on. It is frame is sent. The receiver will send the acknowledgement, and acknowledgement is received within that time duration. So within that time duration. So therefore, the timer is switched off here. Timer is stopped. Okay. What this case? This case talked about the frame is lost. The frame is lost, but the timer expires. Okay. Now the second case in this. Second case here. This is we are talking about the third frame now. The third frame is sent. You see here, third frame is sent, but third frame is received without error. Is received without error. No error. For that, the acknowledgement is sent. Acknowledgement is sent here. But acknowledgement is lost now. Acknowledgement ACK frame. ACK frame is acknowledgement frame. ACK frame is lost during transmission. That possibility is there. Okay. So ACK is lost. And here you see, for the third frame, the timer is switched on. Timer expires. Timer expires here. But why timer expires? Timer expires, and sender will think that frame as not received by the receiver. That is frame number 3 here. Frame number 3 is not received by the receiver because acknowledgement is not received within the stipulated time. So therefore, frame is sent. Which frame is resent? This frame. Frame number 3 is resent. Frame number 3 is resent. Okay. Then acknowledgement frame is sent for that, and it is received within the stipulated time or time duration. But here you think that this is we were talking about the frame number 3 is received, but acknowledgement is lost. Here frame number 3 only is resent. Okay, it is a duplicate copy of this. This duplicate copy of this, it has to be discarded by the receiver. How it is discarded? How the receiver will know that it is a duplicate frame? That is the question here. Okay, that is the question here. That problem is to be solved. For that, we have sequence and acknowledgement numbers. Every frame will have a sequence and acknowledgement numbers. What is that? To correct duplicate problem, we need to add a sequence number to the data frame. and acknowledgement numbers to the acknowledgement frame. Okay, sequence number and acknowledgement number. These sequence number are just 1 bits. It is sufficient here, 1 minute. 0, 1, 0, 1, 0, 1. They are actually added in the header. So this is one more field which is there in the header. They are actually added in the header. So 0, 1, 0, 1, 0, 1. This is a 0 is the sequence number of the first frame. 1 is the sequence number of the second frame. Then again the sequence number are repeated. This 0 is the sequence number of the third frame. It is repeated. Why it is repeated? Why? We can reuse the sequence number because by here, this frame as resent, even if it is lost, then it is resent and acknowledgement is sent, so that we can reuse this sequence number. Otherwise, imagine we have to have for every frame we have to have a new sequence number. Then we have to have too many bits to represent that sequence number. If you have, for example, if you have some 1000 bits, 1000 frames, then we need to have at least 10 bits. We need to have 10 bits. With 10 bits, we can go up to 1024 frames, frame sequence numbers. So we need to have 10 bits to represent the sequence number. So that is, again, remember, all these sequence numbers are redundant bits which are added in the header. That will consume your bandwidth. So therefore, we have to minimize that. So in that we can reuse the sequence number here. Just the acknowledgement numbers are also similar to that. It is the acknowledgement numbers can also be. It is now reverse. It is similar to that. 1 0 1 0 1 0. In other words, start with the 0. The acknowledgement numbers start with 1 here. Okay. Sequence numbers start with 0 and acknowledgement number starts with 1. Let us take how they are used. Let us take this example here. Now in this example, you see here. Frame 0 is sent. Frame 0. It's a sequence number. Frame 0 means sequence number 0 with the first frame. It is sent and it is acknowledged. But here the acknowledgement number is 1. Acknowledgement number is 1. Okay. What is that acknowledgement number 1? What is the meaning of this acknowledgement number 1? Means here in this part, since this acknowledgement number 1 is there, it is indicating the sender, that is, receiver is informing the sender that the next frames to be sent is frame number 1. Frame number 1 here. Okay, frame number 1. This is not the sequence number of the frame 0, sequence number of the next frame to be sent. That is the acknowledgement number. Okay, so here frame 0 is sent. It is acknowledgement. ACK1 is sent. This is timer is switched on here. Timer is stopped. Now second frame here. The second frame, its acknowledged number is 1. Why it is 1? Because the receiver here, ACK has 1. So that this has to send with the sequence number 1. So frame with sequence number 1. But it is lost during transmission. And at the same time, the timer is now running. Timer is switched on and running. Here, the timer expires. Timer expires. That means the acknowledgement number or acknowledgement has not received. What is the expected acknowledgement number for this one? Acknowledgement ACK0. ACK0. Okay. So ACK0 is not received here. So frame 1 is now resent. Frame 1 is resent. Okay. So now frame 1 is resent. ACK0 because it is 1 now. It is received. So ACK0. What is the meaning of this now? That is the frame with sequence number 0. Sequence number 0 means it is now third frame here. Okay. So timer is switched on here. Timer stops here because acknowledgement is 0. Now frame 0 is sent. Frame 0 means third frame here. Because ACK0 is sent. This is 0. So frame 0 is sent here now. Frame 0 is sent. Again timer is switched on. Frame 0 is sent. But now the case you see there. The case where the acknowledgement is lost now. Acknowledgement lost. Acknowledgement is lost. Now, since the timer expires somewhere here, timer expires, the sender will think that the frame 0 as not received by the receiver. So, therefore, frame 0 is resent here. Resent. Frame 0 is resent. Okay. Now, the star mark you see here. The star mark here. It is now discarded. Frame 0 is discarded. Why? Why frame 0 is discarded? Because frame 0 is already received. The sequence number of this frame and sequence number of this frame both are same. The receiver will think that or come to a conclusion that it is the duplicate frame. So it is discarded. It is discarded. Okay. Now the ACK1 is resent. The ACK1 is for this 0. ACK1 is resent. Now after that, what is the next frame to be sent? With the frame 1 it is. Frame 1 is sent because the acknowledgement 1 is this one. So this is how the acknowledgement number and sequence number helps. So this problem now, the duplicate problem is now solved by using frame sequence number and acknowledgement number. Okay, what are the frame sequence numbers used here? 010101, only 1 bit frame sequence number, and acknowledgement number is 101010. It is. Okay, so this is the stop and wait protocol. Stop and